Hi, in this video, we're going to look at finding the positive square root of sets in the form k plus k square root of c. I'm Gideon and T. Let's consider two positive integers a and b. Let's also consider the square root of a plus square root of b. Expanding this will give us a plus 2 square root of ab plus b. By grouping of like terms, we have a plus b plus 2 square root of ab. Now, because a and b are two constants, the sum of a and b will be another constant, which, let's say k, which is also an integer. In the same way, the product of a and b will be another constant, let's say c, which is also an integer. By substitution, our expansion becomes k plus 2 square root of c. Now, taking the positive square root at both sides of the equation, we get the positive square root of k plus 2 square root of c to be square root of a plus square root of b. This implies that the positive square root of sets in the form k plus or minus k square root of c is equal to square root of a plus or minus square root of b. Now, what this means is that when the set is expressed as the sum of an integer and a set, the positive square root is expressed as the sum of two sets. In the same way, when the set is expressed as the difference between an integer and a set, the positive square root is the difference between two sets. Let's look at an example. To find the positive square root of 11 plus 2 square root of 28, we let our positive square root of 11 plus 2 square root of 28 to be the square root of a plus square root of b. Squaring both sides of the equation, we have 11 plus 2 square root of 28 equal to the square root of a plus square root of b. Expanding the right hand of the equation, we get a plus b plus 2 square root of ab. Now, by comparison, we see that a plus b is equal to 11. In the same way, the product of a and b is equal to 28. Now, solving these two equations simultaneously, from equation 1, we have b is equal to 11 minus a. Substituting b is equal to 11 minus a into equation 2, we get a times 11 minus a equal to 28. By expanding and simplifying, we get a quadratic equation a squared minus 11a plus 28 equal to 0. Factorizing the quadratic equation, we get a minus 7 times a minus 4 equal to 0. Solving this equation, we get a is equal to 7, a is equal to 4. But we know that b is equal to 11 minus a. So when a is equal to 7, b is equal to 4. In the same way, when a is equal to 4, b is equal to 7. Therefore, our positive square root of 11 plus 2 square root of 28 becomes square root of 4 plus square root of 7. Now, simplifying further, we have 2 plus square root of 7. Square root of 4 is 2. Square root of 7 is a set, so we leave it. Now, this solution was obtained by considering the case when a is equal to 4 and b is equal to 7. We can also consider the case where a is equal to 7 and b is equal to 4. And by considering this case, our solution will be square root of 7 plus square root of 4. By further simplification, we get our solution to be square root of 7 plus square root of 2, which is the same as this because addition is commutative. So this is our solution for the positive square root of 11 plus 32 square root of 28. Let's consider another example. To find the positive square root of 32 minus 6 square root of 15, we let our positive square root of 32 minus 6 square root of 15 to be square root of a minus square root of b. In this case, we let our positive square root of the surd to be square root of a minus square root of b because the surd was expressed as the difference between 32 and 6 square root of 15. Now squaring both sides of the equation, we get 32 minus 6 square root of 15 equal to the square root of a minus square root of b. Expanding the right hand, we get a plus b minus 2 square root of ab. By comparison, we get a plus b equal to 32. Therefore, a is equal to 32 minus b. By comparison again, we see that 6 square root of 15 is equal to 2 square root of ab. Now squaring both sides, we get 540 equal to 4ab. Dividing both sides by 4, we get 135 equal to ab. But in equation 1, a is equal to 32 minus b. Therefore, substituting a is equal to 32 minus b into equation 2, we get 135 equal to b times 32 minus b. By expanding and simplifying, we get the quadratic equation b squared minus 32b plus 135 equal to 0. By factorization, we get b minus 5 times b minus 27 equal to 0. Solving this equation, we get b is equal to 5 and b is equal to 27. But from equation 1, a is equal to 32 minus b. Therefore, when b is equal to 5, a is equal to 27. And when b is equal to 27, a is equal to 5. In this case, we shall consider the solutions for both cases when b is equal to 5 and a is equal to 27, and b is equal to 27 and a is equal to 5. So let's consider the situation where b is equal to 5 and a is equal to 27. In this case, our positive square root of 32 minus 6 square root of 15 becomes square root of 27 minus square root of 5, because our positive square root was equal to square root of a minus square root of b. In this case, our a is 27, our b is equal to 5. By further simplification, square root of 27 is 3 square root of 3, and square root of 5 is a surd, so we leave it. So our positive square root of 32 minus 6 square root of 15 is equal to 3 square root of 3 minus square root of 5, by considering this case where b is equal to 5 and a is equal to 27. Now let's consider the case where b is equal to 27 and a is equal to 5. In this case, our positive square root for the surd will be square root of 5 minus square root of 27. By further simplification, our solution becomes 5 minus 3 square root of 5. Our solution becomes 5 square root of 5 minus 3 square root of 3. Therefore, our positive square root for the surd 32 minus 6 square root of 15 is 3 square root of 3 minus square root of 5, or square root of 5 minus 3 square root of 3. These are the two solutions for the positive square root of 32 minus 6 square root of 15. We are considering both solutions because in this case, subtraction is not commutative. Now you can check whether this solution is correct by squaring each of them. So you can pause the video and check the expansion. Now by squaring each of the solutions, we get our answer to be 32 minus 6 square root of 15, which is the same as the original set given to us to find the positive square root of. Therefore, in this video, we learned that the positive square root of sets in the form k plus q square root of c is given as the sum of two sets. In the same way, the positive square root of sets expressed in the form of k minus q square root of c is equal to the differences between two sets. Thank you for watching.